Hello there. We are now in part 3 of quadratic equations. What we have done in part 1 is we define quadratic equations and we apply technique of solving quadratic equation by factorization. In part 2, what we have done mainly is solving quadratic equation by completing square technique. In part 3, what we are going to do today is solving quadratic equations using quadratic formula. Here, this part 3 is technically the same as part 2, which is solving quadratic equation by completing square. So, to understand part 2 is helping much to understand this part of the topic. The last thing, probably the fourth and the fifth parts of this quadratic equation lesson is going to be understanding the characteristics of the graphs of quadratic equations, and we define functions and how it operates on the graphs. That is going to be more interesting part. This technique is using a quadratic equation formula derived from a general expression of a quadratic equation, that is ax squared plus bx plus c is equal to 0. As discussed earlier, a, b, and c are real numbers and a is different from 0. The very first reason why a is different from 0 is that for a is equal to 0, ax squared is equal to 0. And the remaining terms of the expression will be bx plus b is equal to 0, which is a linear equation instead. So a quadratic equation is defined in such a way that ax squared plus bx plus is equal to 0, where a is different from 0. As we have already used the technique of completing square, we use the same technique to derive a general formula for a quadratic equation. The standard form of a quadratic equation is that ax squared plus bx plus c is equal to 0, where a, b, and c are constants and elements of real numbers, and a is different from 0. The first step of completing square, in which we have discussed this one in detail in part 2 of this quadratic equations lesson, is that to convert the leading coefficient to 1. The leading coefficient is a. In this case, we have to convert a to 1. How we convert a to 1 is that we divide both sides of the expression by a. Both sides means one side is ax squared plus bx plus c, and the other side is 0. When we divide both sides of this expression by a, we will have a leading coefficient of 1, which is the first step of completing square. As we have again, remember, the second step is going to be find out half of the middle term and square it and add it somewhere here. At the same time, subtract it. Then we do a completing square in this part. This is in detail discussed in part of this topic, quadratic equations. So ax squared plus bx plus c is equal to 0. We divide both sides by a. Dividing both sides by a is technically means multiplying both sides by 1 over a. It's the same thing. So this a is going to be distributed throughout the parentheses. It goes for all. What will happen when it goes for all? This is one of the distribution characteristics of multiplication over addition here. So ax squared divided by a plus bx divided by a plus c divided by a is equal to 0 divided by a, which is 0. When we divide this expression, both sides of this expression by a, we end up with x squared plus b over a x plus c over a is equal to 0. It's the first step of completing square. What is the second step? The second step is we take half of the middle term and square it. Once we square it, we add it. At the same time, we subtract it. Why we add it and subtract it is to maintain a 0 at this point. When we add a number and subtract that same number, we don't make any change on the expression. So b over a is here. Half of b over a is b over 2a, this one. Half of it means multiply it by half. Then you square it. What we will have is b squared divided by 4a squared. b is a square, 2 squared is 4, and a squared is a. It's just something like a over b to the power of m is a to the power of m divided by b to the power of m. So the power is again given to both the numerator and denominator. The same thing happens here. When we square it, we square b and we square 2a. When we square 2a, we will have 4a squared. We will have 4a squared. Let's see what's next here. Now we have x squared plus b over ax. This is what we have here. Now half of b over a is b over 2a. Square of b over 2a is b squared over 4a squared. We add it here. Why we add it here? To do a completing square technique on this side. If we add b squared over 4a squared, we need to subtract that same amount right here. When we add it and subtract it, then the result is 0. 0 is added in the expression, means there is no change in the original expression. C over a, it's there originally and it remains there. Now let's do the completing square technique on this part and keep the other part as it is. Let's see that one on the second page, on the next page. Now we have here a completing square technique is applied here. X squared plus b over 2a x plus b over 2ax. We split b over a into 2 here. We used to have here b over a x. Then when we split this one into 2 equal parts, b over 2a x plus b over 2a again x. That's what's happening here. And then b squared divided by 4a squared. This is plus here and a minus here. We deduct it at the same time here. Plus c over a. Why we split this one into 2 is because we have to take now a common factor and then distribute to make it a completing square technique. Now here, let's take x, a common factor here, because x squared is xx. So we have one x here, we have another x here. When we take x out here, we will have one x here, x plus b over 2a. This x is out here, out of the parenthesis here. Again, the next one, from the second term, this part, what we take as a common is b over 2a. b over 2a as a common, then we have 1x here, and then we have b over 2a. b over 2a times b over 2a is b squared over 4a squared. So we can take b over 2a here, we still have a b over 2a there. Just cool. Then minus b squared over 4a squared plus c over a, we keep this one. Now what common we have here is one part is this one, other part is this one. This and this are now the same. So we take this as a common here, x plus b over a as a common. We will have 1x here. We will have 1 b over 2a here. Then it becomes this one. This is a reverse process of distribution. We have discussed this one in the part 2. Now what we have, two same terms here, x plus b over a, x plus b over a. X plus b over a and x plus b over a will give us x plus b over a square. It is simply to mean x times x is equal to x square, because x to the power of 1 times x to the power of 1 is equal to x to the power of 1 plus 1, which is x square. So this one is x plus b over 2a, the whole square, is equal to, we still have the same thing here, minus b over 4a squared is negative, c over a is positive. So when we move these two terms in the other end of the other side of the equality sign, it changes the signs. Minus b squared divided by 4a squared will be a plus, c over a will be a minus. Technically, what we do here, we add this side a plus b squared over 4a squared. At the same time, we add that side as well, b squared over 4a squared. When we add a positive here and then we add a positive here, this side cancels out. So what we simply say, when we move it to the other side of the equality sign, so we have to change the sign, a plus to a minus and a minus to a plus. So this is what it is. The next step here, x plus b over 2a whole square is equal to, let's make a similar denominator so that we can add the numerators easily. So to make a similar denominator, we got here 4a squared, but we got here only a. When we have only a, we need one number 4 and 1a here. To multiply it with a, it is 4a squared. So we have to multiply this one, a numerator as well a denominator, by 4a. When we do that, the numerator c will be 4ac, the denominator a will be 4a squared. Now we have a similar denominator, then we can add the numerators. So what it will be, x plus b over 2a the whole square is equal to b squared minus 4ac, which is this one here, divided by 4a squared. Once we have x plus b over 2a the whole square, we put this side in a square root. In a square root, the one which is in the bracket altogether in a square root means we multiply the exponent by 1/2. At the same time, we have to do the same thing on the other side. We multiply the exponent here, 1 originally, by 1/2. So this part will be b squared minus 4ac over 4a squared in a square root, or exponent half. So this is here. At the same time here, 2 times 1/2 is 1, so we don't need to have anything. X plus b over 2a is a plus or minus. When we put it in the square root here, a plus or a minus. And in the square root, b squared minus 4ac over 4a squared. It is something like, if x squared is just a 9, example, just I'm giving one piece of example, x can be a plus 3 or a minus 3. That is because the square of a plus 3 is 9, the square of a minus 3 is also 9 at the same time. So if x squared is 9, x could be a plus or a minus of that square root of 9, which is going to be a plus or a minus 3. So that's why we have to put a plus or a minus, because the square of both negative and positive numbers will give us a positive result. Now once we have this, x plus 2a is equal to plus or minus, let's divide this square root for the numerators and denominators. We can split it, that's okay. That's okay in a sense, we have said it a over b to the power of m is a to the power of m divided by b to the power of m. We can do that. So if we do that, the square root, which is a power of half, that's a number. So we can put it the upper side, b squared minus 4ac in a square root. Again, 4a square in a square root. Now 4a square is easy to get it out of the square root because 4 is 2 times 2. A square is a times a. We have 2 times 2. We take 1 2 out. We have a times a. We take 1a out. Then it's going to be 2a. X plus b over 2a is equal to plus or minus square root of b squared minus 4ac divided by 2a. Now we add minus b over 2a on both sides. This will cancel out and we will have minus b over 2a on the other side of the equality sign. So x is equal to minus b over 2a plus or minus b squared minus 4ac over 2a. We can notice here also that we have the same denominator, so we can put a common denominator for both minus b and square root of b squared minus 4ac. That looks like x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. Now we know what is a, what's b, and what's c from the general expression of a quadratic equation. Then x is the solution set for that given quadratic equation is minus b, one of them is a plus, square root of b squared minus 4ac over 2a. The other one is minus b minus square root of b squared minus 4ac over 2a. Instead of using the completing square technique for each and every question, now it is easy to remember this one and then apply it directly to the formula. This is what we call it solving quadratic equation using quadratic equation formula. This is a quadratic equation formula. In this general quadratic equation formula, the number and type of the solution set are purely depend on the value of b squared minus 4ac. Why b squared minus 4ac is of special attention here is that it is in the square root. If a number is in the square root, it has to be positive for a real number solution to be a real number. So this part determines what type of solution sets we have within a given quadratic equation. What type and what number, in fact. What type in a sense, b squared minus 4ac has to be greater than 0 for a real solution. But if b squared minus 4ac is less than 0, a negative number in a square root is not defined in real number domain. So we will not have a real solution. We will rather have a complex solution. Another thing, if b squared minus 4ac is equal to 0, that means this part is 0. So the solution set we will have will be minus b over 2a, which is only one solution set in this case. So the characteristic of the solution set is mainly depend on the value of b squared minus 4ac. The term b squared minus 4ac is called discriminant. There are three cases for a discriminant. Case number 1, if b squared minus 4ac is greater than 0, then square root of b squared minus 4ac is a positive number. We can say d, or we can keep it as it is. Then the solution set will be minus b plus or minus d over 2a, or simply minus b plus or minus square root of b squared minus 4ac over 2a. So we have two. One is a plus, one is a minus, two solutions. These solutions are real numbers because the square root of a number has to be, if a number is in a square root, it has to be positive for a real number domain, or to have an output in the real number system. But if this is negative, it's not a real number anymore. For example, the square root of minus 4. There is no such a result for this one, because there is no number in which when you square it, it gives you a negative in the real number system. But there is a set of domain in a complex number in which the square of a negative number could be meaningful in a complex number world. The other one, if b squared minus 4ac is equal to 0, so the solution set is going to be minus b over 2a. It is only one solution set, which is a real number, and the value is minus b over 2a. The third condition for b squared minus 4ac is when b squared minus 4ac is less than 0, then it's undefined in the domain of real numbers. We can still have a solution set of a complex number in this case, no problem. This means that if b squared minus 4ac is less than 0, then 4ac minus b squared, the other way around, is greater than 0. So in that case, what we can do, minus 1 times 4ac minus b squared. We can call it like that. This is positive. So minus 1 can be treated as a separate number. For example, if we have minus 4 in the complex number world, it means what? Square root of minus 4 is square root of minus 1 and 4. We just split it into 2. Then it is square root of minus 1 and square root of 4. Square root of 4 is just 2. So square root of minus 1 is defined as iota. So it is just like 2 iota. We can take it like that way in a complex number world. We're going to do more exercise on this one, and no need to worry much about it now. So if b squared minus 4ac, but b squared minus 4ac is minus 1 times 4ac minus b squared. So b squared minus 4ac is equal to minus 1 times 4ac minus b squared, which is 4ac minus b squared is here, minus 1 is here. Minus 1 is just iota. 4ac minus b squared is now a real number because b squared minus 4ac is negative, then 4ac minus b squared is positive. This part is now positive, and we can have a real number on this part, and we can have iota here. So if we have a plus bi is a complex number, even if a is a real number, b is a real number, the whole expression is a complex number, which we have discussed this one in part 2 as well. So the two complex solutions of this quadratic equation will be minus b plus square root of 4ac minus b squared, just to get the positive part, and then iota divided by 2a. The other one, minus b minus. The only thing is that we still have two complex solutions. One is a plus here, another one is a minus here. There are two complex solutions in this case now. The two complex solutions, we can have two complex solutions, we can have two real solutions, we can have one real solution. These are the cases. So let's do one example now here by applying the general formula for quadratic equation. The question is 3x squared is equal to 5x minus 1. Now what we do, we have to collect all the terms. This is 5x, and the other one is here 1 or minus 1 to the other side of the equality sign to get the general form of a quadratic equation. That's the first thing we do. So when 5x is in the other side, we can move it by changing a plus sign to a minus, or simply in the formal way, we add here minus 5x, at the same time we add here minus 5x, we add here a plus 1, at the same time we add there also a plus 1, This side is going to be 0. This side is going to be 3x squared minus 5x plus 1. 3x squared minus 5x plus 1 is equal to 0. Now what we have here, we don't need to do now a completing square anymore. In the completing square process, we apply it for each and every question. The first step was to get the general form of the quadratic equation. The second step was to convert the leading coefficient into 1. In this case, now we don't do this because in the formula, we have done all the necessary steps and created a general formula for quadratic equation solution sets. And then we just apply the formula instead. What we have here, A is 3, B is minus 5, C is 1. So what is B squared minus 4AC? The discriminant value is an important value that gives us a clue of what is going to happen in the solution sets. Will it be one real solution? Will it be two real solutions, or will it be two complex solutions? That will be determined by getting the value of b squared minus 4ac, or which is a discriminant. So b squared is minus 5 squared, minus 4, a is 3, c is 1. So 25 minus 12, 13. From this value, now we know that we will have two real solutions. So x is minus b plus or minus square root of b squared minus 4ac over 2a. When we do this one, when we get the value of b squared minus 4ac, we have done two things. One thing, we now know the characteristic of the solution sets. The other thing, we have solved b squared minus 4ac, in which we don't need to do it again. We just only substitute that value here in place of b squared minus 4ac. So what's minus b? Minus b is minus 5. Minus 5 is a plus 5. So it's a 5, a plus or minus. Now we know b squared minus 4ac is 13. So here we will have square root of 13. 2a is 2 times 3, which is 2 times 3 is 6. So we will have two solution sets. One is 5 plus square root of 13 over 6. The other one is 5 minus square root of 13 over 6. It is simply by applying the formula for quadratic equations. This is what we have discussed now. Example 2. X squared minus 3x plus 2 is equal to 0. This is in the general form of a quadratic equation. Good. What's the value of A? A is 1. What's the value of B? B is minus 3. And the last one, the value of C is 2. Now we have A, 1, B, minus 3, and C, 2. What is B squared minus 4AC? B squared is minus 3 squared, which is 9. 4AC is 4 times 1 times 2, which is 4 times 2 or 8, 8. So b squared minus 4ac is 1. From the value of b squared minus 4ac, now we know that we have two real solutions. Okay, the general formula for a quadratic equation is minus b plus or minus square root of b squared minus 4ac divided by 2a. Minus b is minus 3, then minus b is 3. Minus b plus or minus square root of b squared minus 4ac divided by 2 times a. 2 times 1 is 2. The square root of 1 is just 1. 3 plus or minus 1 divided by 2 is either 3 plus 1, which is 4 divided by 2, or 3 minus 1 is 2 divided by 2. So we have two solution sets. One is 2, the other one is just 1. So these are the two solution sets of this quadratic equation. We have another example here. The equation is 4x squared minus 11x plus 6 is equal to 0. The value of a is 4, b is minus 11, and c is 6. b squared minus 4ac is, which is a discriminant value, b squared, which is minus 11 squared, is 121. Minus 4ac is minus 4. We have minus 4. A is 4 and c is 6, which is minus 4 times 6, which is 96. 121 minus 96 is 25. Now b squared minus 4ac is 25. Square root of b squared minus 4ac is plus or minus 5. Normally, if we talk about square root of 25, which is definitely 5, but the square of a number is 25, then that number is a result of the positive or the negative part of that same 25, which is plus or minus 5. So, now we have b squared minus 4ac, square root of 25, minus b. b is minus 11, minus b is minus 11, which is plus 11. So 11 plus 5 divided by 8, or 11 minus 5 divided by 8. 11 plus 5 is 16. 16 divided by 8 is 2, or 11 minus 5 is 6. 11 minus 5 is 6. 6 divided by 8 is 3/4. So the two solution sets are 2 and 3/4. Let's go for another example here. X squared plus 3 is equal to 2x. This term is not in the general form of a quadratic equation, not in the standard form. So we have to convert it to standard form. Standard form is in such a way that ax squared plus bx plus c. X is x to the power of 1, c is c times x to the power of 0, we can call it. So here, 2, 1, and 0, it has to go this way, from highest degree to the lowest degree order. So the standard form is x squared minus 2x plus 3 is equal to 0. Here, in x squared minus 2x plus 3 is equal to 0, a is 1, b is minus 2, c is 3. A is 1, b is minus 2, and c is 3. b squared minus 4ac, which is a discriminant, is minus 2 squared, which is 4, minus 4a, which is 1, c is 3, minus 4 times 1 times 3 is minus 12. So 4 minus 12 is minus 8. The discriminant is negative. When a discriminant is negative, we will have two solution sets which are not real numbers. So we have two complex solution sets. Now, in the general formula of a quadratic equation, we have x is equal to minus b. Minus b is minus 2, which is 2, plus or minus square root of minus 8. How we simplify square root of minus 8? It is here. A square root of minus 8 is a square root of minus 1 times 8. We split it here, which is square root of minus 1 times square root of 8. Square root of minus 1 is simply I. Square root of 8 is square root of 2 times 2 times 2. When we have two pairs here, when we have a pair here, we take one of them out, and then we still have one in the square root. So square root of 8 is 2 root 2. So this part, the b squared minus 4ac part, is 2 root 2 I, or simply we can put I in the front, I times 2 root 2. This is to avoid a confusion of looking I in square root, we can put it in the front. But it's very clear that I is separately out of the square root. So b squared minus 4ac is there. We have it here, 2 root 2i. And then here we have plus 2. And then divided by 2a is 2 times 1. A is 1, which is 2. So x is, now we can split it into 2. The denominator can be split into 2. It depends on the convenience. So this way or that way, it doesn't matter. Now here x is equal to 2 divided by 2 plus or minus 2 root 2 divided by 2, which is, this part is 1, this part is root 2. 1 plus or minus root 2i. The two solution sets are 1 plus root 2i and 1 minus root 2i. We have two solution sets which are complex numbers. Next example here. 6x squared plus x minus 15 is equal to 0. This is in the standard form. No rearrangement is required. b squared minus 4ac, which is b is 1 here, 1 square minus 4 times 6 times minus 15, which is going to be a plus. 1 is here, 1 is here. When we have two negatives here, the result is going to be a positive. Then 1 plus 360, which is 361. This is a discriminant part. So when we have a positive discriminant, it means that we have two solution sets which are real numbers. So the formula is x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a, which is minus 1 plus or minus square root of 361 divided by 2 times 6. Square root of 261 is 19, so minus 1 plus or minus 19 over 12, which is minus 1. 1 is minus 19 over 12, the other one is a plus 19 over 12, which is minus 20 over 12 or minus 5 over 3. The other one is 18 over 12, which is 3 over 2. These are the two solution sets of this quadratic equation. Now we have two real solutions, which are minus 5 over 3 and 3 over 2. Any quadratic equation has one or two solutions. If b squared minus 4ac, this as a summary, is less than 0, and the scope of the solution, or simply the domain of the solution, is real numbers, then we may consider that there are no real solutions. Here we can say no real solutions if a discriminant is negative. But it doesn't mean there are no solutions. But it means there are no solutions in the real number domain, or the solutions are not real numbers. That's just are not real numbers, but we still have complex solutions. Now, there are extra operations in quadratic equation solution sets, which we find them in different exams. One is the sum of the roots. Another one is the product of the roots. Probably we can also add extra operations in roots. But for now, in this topic, we can at least see the sum of the roots of a quadratic equation and the product of the roots of a quadratic equation. Further analysis on roots of a quadratic equation can go up to difference of a quadratic equation. But the drawback on the difference of a quadratic equation is that subtraction is not commutative. So when we think about the two solution sets, say, I can say roots R1 and R2. If we talk about R1 minus R2, which is different from R2 minus R1, unless and otherwise R1 and R2 are equal numbers, it means that subtraction is not commutative. So when we talk about differences of the roots of a quadratic equation, we might have two results for the differences. One is R1 minus R2, The other one is R2 minus R1. In this case, maybe we can say a possible differences, one is a possible, and we can have a choice of a best answer, but it's not much important to worry that thing. We can at least say the sum of roots, easy to get one unique. The product of roots of a quadratic equation, we can also get one unique answer for this. Sum of the roots of a quadratic equation. For a quadratic equation of the form ax squared plus bx plus c is equal to 0, where a is different from 0, that's a definition. Root 1, we know it, we have the formula for it, is minus b over 2a plus b squared minus 4ac over 2a. Root 2 is minus b over 2a minus b squared minus 4ac over 2a. What will happen if we add root 1 and root 2 directly from these formulas? It's going to be like minus b over 2a plus b squared minus 4ac over 2a. Now when we add the second one, minus b over 2a minus square root of b squared minus 4ac over 2a, we are adding here. We are adding them. It means that these two will cancel out here, but we will have minus b over 2a and another one minus b over 2a, which is minus b over a. Half of minus b over a plus another half of minus b over a is 1 full minus b over a. So the sum of roots of a quadratic equation is minus b over a, where a and b are the leading coefficient. A is the leading coefficient or a coefficient of x squared, and b is a coefficient of x. We know what is a, we know what's b from the general formula of a quadratic equation. Then r1 plus r2 is minus b over a. We don't need to solve a quadratic equation if we are asked the sum of the roots. We simply take a, we simply take b, so r1 plus r2 is minus b over a. We will give more example, or simply what? For example, we have a quadratic equation, 4x squared plus 2x plus 4 is equal to 0. We have two solution sets on this quadratic equation. It could be two real solutions, okay. It could be two complex solutions, that's also okay. It could be only one solution, which is when the discriminant is 0. In that case also, we can assume we have two solutions. It doesn't matter because minus b plus or minus square root of b squared minus 4ac over 2a. When we have this one, if the discriminant is 0, we still have one solution minus b over 2a, and the other solution, which is plus 0 here, minus b over 2a, which is minus 0. Technically, one is plus 0, one is minus 0. It means what? It means 0 is 0. It doesn't make any change. So this is a unique and one solution set for this quadratic equation. But when we talk about the sum of the roots of this quadratic equation, we can simply add these two. So it is 2 times that unique solution. So minus b over 2a plus minus b over 2a is minus b over a. So it doesn't matter. We have two solution sets or even one solution set on a given quadratic equation. When we talk about the sum of the roots of this equation, we simply take minus b over a and that's it. So 4x squared plus 2x plus 4 is equal to 0. A is 4, b is 2, c is 4. So the sum of the roots of this quadratic equation, we don't need to solve and find out what they are, is minus b over a, which is minus 2 over 4, which is minus half. That's it. So the sum of the roots of this quadratic equation is minus half, minus 1 over 2. We can also say the average of the roots of the quadratic equation. Okay, if we want to say, we can say the average, if we know the sum, Then the average is just divided by 2. We might think we have only one solution set, and the average of 1, it doesn't give sense for an average of a single value. But what we have to do, we assume again we have two solution sets. One is minus b over a is the sum. Then the sum of the two is minus b over a. Then the average of the sum of the two is just minus b over a divided by 2, which is minus b over 2a. We can assume that way. So the average of the roots of a given quadratic equation is minus b over 2a. I think there is no logic to ask such questions, but we need to know that. The third characteristics of the roots of quadratic equations is about the product of the roots. This part is interesting part because we're going to apply difference of two squares formula to find out the product of the roots. One root is minus b over 2a plus b squared minus 4ac over 2a. The other root is minus b over 2a minus b squared minus 4ac over 2a. So what is the product of these two? Assume this part is a, assume this part is b. So the same a is here, the same b is here. Now if a plus b times a minus b is equal to a square minus b square. This is a difference of two squares, which we have discussed it in part 2 of this quadratic equations lesson. Let's see. Note for two numbers. Now here this note is given as k and l. K plus l times k minus l is equal to k into k minus l plus L into K minus L. This K goes for both. This is a distribution property. This L goes for both. In that case, this K will take K minus L. This L will take K minus L, which is, let's distribute that one. K by K is K squared. K by minus L is minus KL. L times K is LK. L times L is minus L squared because we have a negative here, we have a negative here. Here, KL and LK are the same. It's a commutative property of multiplication. So KL, LK, they are the same, but having a different sign, so they cancel out. So it becomes like K squared minus L squared. Once we have this characteristic, how are we going to derive the product of the roots of a given quadratic equation? The product of these two numbers is the first one square minus the second one square. This is the difference of two squares, which we have seen just now. Minus b over 2a square is minus will cancel out because it's just minus will be a plus as it is the product of two negative numbers is a positive. So b square divided by 4a square, which is minus b square, and 2a square. Minus b square is a b square. 2a square is 4a square. Minus this square here, the square root of this, the upper term, b square minus 4ac will be eliminated. And it will be 4 minus b square minus 4ac, this part, no square roots now. 2a will be 4a square. Now we have same denominator. That's one of the good things here. So let's just split this term here, b square minus 4ac. So b square divided by 4a square here. The next one, minus b square divided by 4a square. The third one, because there is a parenthesis here, negative times negative will be positive, plus 4ac over 4a square. Now we got 4a square in common for all the three terms. We keep it here. Now we have b square minus b square, which is cancel out and then nothing. Then we have 4ac divided by 4a square. We have here it means what? 4ac divided by 4aa. A square is aa. So 4 cancels out. A and A will cancel out. We will have only C over A. So the product of the roots of a quadratic equation is C over A. We keep in mind these things. Minus B over A, C over A, B squared minus 4AC, minus B plus or minus square root of B squared minus 4AC divided by 2A. These things are just very much elementary to remember in any field, especially in the engineering field, in an architecture or in civil engineering or in most fields. We need to know the general formula for a quadratic equation. Not much, but it's good to know the sum and the product and the average of the two roots of a given quadratic equation. So now we have the product of the roots of a quadratic equation is C over A. Now let's see here, find the sum, average, and product of the roots of the quadratic equation. 3x squared is equal to 5x minus 1. Let's put it first in the general expression format, in the standard expression format, which is 3x squared minus 5x plus 1 is equal to 0. A is equal to 3, B is equal to minus 5, C is equal to 1. The sum of the roots of this quadratic equation is minus B over A, which is 5 over 3. Sum is 5 over 3. The product is C over A, which is product 1 over 3. The average is a sum divided by half. Just we apply the formula. So 3x squared minus 5x plus 1 is equal to 0. We have A, we have B, and we have C. Sum R1 plus R2 is minus B over A, which is minus 5 over 3, or simply 5 over 3. The average is half of the sum, which is 5 over 6. The product of the roots of a quadratic equation is C over A, which is 1/3. Earlier, it's been obtained that the roots of 3x squared is equal to 5x minus 1. These are, we have done this example, 5 plus root 13 over 6 and 5 minus root 13 over 6. The sum of these two roots is, we can add them here, and we end up with 5 over 3. The sum of these roots is 5 over 3. It's simple. We can see it here. What we have to cancel out, we can see when we add these two, it's going to be 2 times 5 over 6 is 5 over 3. The product of R1 and R2 is the difference of two squares, something we can apply. We have applied already when we derive the formula. So we end up with 1 over 3. Here we split it into 2, 5 over 6 and root 13 over 6. Here also we split it into 2, 5 over 6 minus root 13 over 6. Here we can see these two terms are the same and these two terms are the same. The only thing is a difference of the sign. So we can apply difference of two squares, which is 5 over 6 square minus root 13 over 6 square. Root 13 over 6 whole square is 13 over 36. 5 over 6 whole square is 25 over 36. The denominator is common here. We keep that one. 25 minus 13 is 12. It is just 12 over 36. When we divide both sides by 12, we will have 1 over 3. Let's have another example here. We find the sum, the average, and the product of roots of a quadratic equation. 3x squared plus 6x plus 3 is equal to 0. A is equal to 3 because it's a standard form. we don't need to do anything in rearranging it to the standard form. It's already given us a standard form. A is 3, B is 6, C is 3. The sum of the sum of the roots is minus b over a, which is minus 6 over 3, minus 2. The product of the roots is c over a, which is 3 divided by 3, 1. C over a, it should be, which one is this one? The average, this is the average here, sorry. When we have the sum here, and then half of the sum is the average. The product is 1, that's correct. When we solve this quadratic equation, which is the same as the previous one we have done there, 3x squared plus 6x plus 3, let's be sure, 3x squared plus 6x plus 3, we can solve this one using completing square method and verify the answer. We can solve using completing square method, and or we can solve using the general quadratic formula, but it's just here it's written as using completing square, so it's just fine. For completing square, what we have to do, leading coefficient has to be 1, so divide both terms by 3, then we will have x squared plus 2x plus 1, x squared plus, no, when we divide this one by 3, which is 2, there is something wrong here, needs to be corrected. 3x squared plus 6x plus 3, when we divide both sides by the leading coefficient, we will have 3 by 3 is 1 here, 6 by 3, this has to be 2 instead, and then 3 by 3, it is 1 here, is equal to 0 over 3 is 1. Let's see what will happen. Next, lucky enough, this is 2 here, so we don't need to worry much. So, what we have to do, completing square method tells us that first thing is the leading coefficient has to be 1, that's done already. Second thing, take half of the middle term and square it. Half of 2 is just 1, 1 square is 1, 1 square is 1. So in that case, what we have here, we need to add 1 here, at the same time subtract 1 here, but it is just 1 there, so we don't need to add anything or subtract anything in this case. It's just 1 there, we have 1 there, no different number, so it's just perfect square. So what we have to do, x squared plus x plus 1, we can add and subtract, but the same thing, it doesn't matter because we already have 1 here. So what will happen here, let's use now this part to complete the square, which is x into x plus 1 into x plus 1, which is x plus 1 times x plus 1. This one, minus 1 plus 1 is just 0. So what we have, x plus 1 is equal to 0, or x plus 1 is equal to 0, which is x is equal to minus 1, or x is equal to minus 1. We have only one solution set. But for the sake of the sum of the roots, as we have used the formula, we can simply add them. The sum of the roots is going to be minus 1 and minus 1, which is minus 2. We've said it before already. The product, minus 1 times minus 1 is 1. So we have minus 2 for the sum, which is here, and 1 for the product. This statement is here. Although this equation has only one solution, it is considered to be having two identical solutions for the purpose of just the sum of the roots and product of the roots things. So it's explained already. Let's go for the next one. Now, here we have exercise. Solve the following quadratic equations using quadratic equation formula. Find the sum of the roots of these quadratic equations using the sum formula. Find the products of roots of these quadratic equations using products formula. Find the average of the roots of the quadratic equation using half of the sum of this roots is just the average. And we analyze the answer by getting we can analyze the difference of the roots. We said it, a difference of the roots is same magnitude, but it could be a plus and the other side is a minus b or b minus a. So there is no such a thing. It depends. So we do that one for the following questions. So let me put some questions here as an exercise, and if you want to just give a feedback on the comment, I will accept that one. And the other one, don't forget again to subscribe. 1, 4x squared plus 2x is equal to 4. 2, x squared minus 4x plus 2 is equal to 0. 3, 2x squared is equal to 4x minus 1. 4, 4x minus 6 is equal to x squared. 5, the last one, 6x squared minus 4x minus 2 is equal to 2x. Right, now the fourth part of this quadratic equations is going to be analyzing the graphs, more of colors and more of interesting stuff. So we will see that one, and for today it's just good enough, and have a good day, and thank you.